Hello, I'm Liesel Ehlers. I'm going to present a lesson on Mathematics Level 4, that is in NCV. In our previous lesson, we have looked at the differentiation rules, and then we followed it up by using these differentiation rules to actually answer questions on tangents. For today's lesson, we are going to look at a second application of differentiation, namely rates of change. So let's do some background, get some background information. Firstly, if I have a formula describing distance in terms of time, in other words, the formula will tell me how this object's distance will develop at every single time. And I present this graphically. Then let's put the time on the x-axis and the distance on the y-axis. So I want us to look at the gradient of this distance formula. We can present it graphically, like it can be a straight line, it can maybe be another type of graph, depending on what this distance formula is, which was being given. So the gradient of this distance graph. Remember, the gradient between 2 points is y2 minus y1 over x2 minus x1. So if I use that same formula and I actually apply it to what we have here, then the y value will be, the y2 will be a distance 2 minus the first distance, and the x values will be a time minus a time. So in other words, the gradient will be s2 minus s1 over t2 minus t1. So do you see, actually what I'll get is the difference in distance over the difference in time. Does that sound familiar? Distance over time is velocity. If I write the units, let's say distance was given in meters and the time was given in seconds, maybe that sounds more familiar to you. Now this meters per seconds unit. Meters per second unit for velocity. It could also be, in other cases, kilometer per hour or whatever. So important, what I get is velocity. And what gave this velocity? Velocity is given by the gradient. And the gradient, we already said in our previous lesson, is the derivative, in this case, of the distance formula. So what I know is actually that if I differentiate the distance formula, I'm actually going to end up getting velocity. And then in the similar way, I can put velocity on this y-axis, the horizontal, vertical axis, and time on the horizontal axis, and then I will be able to get, if I look at the gradient, I'll end up having acceleration. So let's summarize this. If I summarize this, if a distance formula is given, the distance formula differentiated will give me velocity. And if I take the velocity formula and I differentiate it, I'll end up having acceleration. So velocity differentiated gives me acceleration. In other words, acceleration is the second derivative of the distance formula. And we are going to use this to answer some questions. Let's look at a few examples. The first example, a rocket is fired up vertically into the air. After t seconds, it reaches a height of st meters, where s is given by this formula. So I have the height is described by this formula. So the height in this case, the height of this rocket, is the distance it's moving upwards. So the first question is, what is the displacement after 2 seconds? Well, the displacement is the distance. In this case, it's the height, it's all the same thing. So the distance or the displacement will be described by s, and they want to know after 2 seconds. So I'm going to replace t also on the other side. Every t must be replaced with a 2. And if I square it there, I'm going to end up having 200 minus 4 times 5, which is 20. So the distance, the height that it will reach after 2 seconds will be 180 meters. The next question is determine the time until this rocket reaches a height of 320 meters. Again, I'm using this height distance formula. So the formula that I have, it says the height is described by 100t minus 5t squared. If the distance, or the height in this case, is 320, then I replace the s with the 320, and that will be equal to the 100t minus 5t squared. Okay, we can see what I have here is a quadratic equation, and therefore I'll have to equate it to 0. Therefore, let's take all the terms to the left-hand side. The 320 was already on the left-hand side, and we equate it to 0. And remember, well, I want to factorize, that will be the next thing to do, but I see that 5 can actually divide into all of these terms. So I can actually divide right through with a 5. So I can actually simplify it a bit before I'm going to factorize it. 5 goes into 120 times. 64 times is equal to 0. Okay, now I have to try and factorize this. T multiplied with t will give me the t square. If this last sign here is a positive, it tells me the signs in the brackets will be the same. And it will be then two negatives, a negative and a negative. So let's think. Factors of 64. I know 2 times 32 is 64, but if I add it up, I'm not going to end up having 20, so I'll have to try something else. 64 is also 4 times 16, and negative 4 minus 16 will give me exactly that negative 20 that I want. So it's going to be negative 4 and negative 16. The one bracket is 0, or the other bracket is 0, which means t will end up being 4 seconds, or t will be equal to 16 seconds. So if I go to my graph, let's say 320 meters is there. If a height of 320 meters is here on my graph. Remember, this graph that I have is representing the distance formula. It's not the rocket as it's traveling up in the air. It goes up vertically up into the air. But the distance formula is given here, graphically represented. So what I can see here is I actually ended up having 2 answers. And the reason for that is because the rocket on its way up, it will reach 320 meters after 4 seconds. And then on its way down, it will again pass that 320 meter height, and that will happen after 16 seconds. The question asked is, determine the velocity of the rocket after 2 seconds. Do you remember what we said in the summary? If I have a distance formula, the velocity will be the derivative of that distance formula. In other words, I have to differentiate the distance formula. If I differentiate the first term, the 1 must be multiplied with 100, and t will be to the power 1 less. Then I take the 2 to the front and multiply it with the negative 5, so it's going to be negative 10 t to the power 1 less. So the velocity is given by the formula 100 minus 10t. I want to know what is the velocity after 2 seconds, so I replace the t with a 2. So it's going to be 100 minus 10 times 2. 100 minus 20 is 80, and the units that they told me to use is meters and for times seconds. In other words, it will be 80 meters per second. Okay, we move to the next question. Still busy with a rocket. Question number 4 says, determine the time taken to reach a maximum height. Okay, so the height in this case is described by this distance formula. So the distance formula is also the height in this case, and it is represented by this graph. So if they want to know where will this graph be at its maximum, it will be there at the turning point. So what do we know? What happens at the turning point? There at the turning point, the gradient is 0. And what did we say is gradient? We said the gradient is the derivative of this specific formula, the distance formula. So the maximum, for maximum height, it will be where the derivative is equal to 0. What is the derivative of the distance formula? Well, it's 100, t to the power 0 minus 10t, and that must then be equal to 0. In other words, the negative 10t is negative 100, which means t will be 10 seconds. So the maximum height will be reached after 10 seconds. So I can put at this stage, I can say there, at 10 seconds, the maximum height will be reached. Now, if the next question is, so what is this maximum height? The maximum height, well, I've got a formula describing height. The formula that I have for height is given there, and I know the time where this maximum will actually happen is after 10 seconds. So I can just use that formula and replace the t with a 10 seconds, which I have just calculated. So replace every t with a 10, which means I'll get 1,000 minus 500 is 500 meters. So at this stage, I can say this maximum height will be 500 meters. Remember we said, and that will happen after 10 seconds. So let's go back to that one. What we said previously is we said after 320, after to reach a height of 320 meters, we said that will happen after 4 seconds and 16 seconds. Okay, last question on the rocket. I've got still this rocket, and they say determine the acceleration of the rocket. Now, what is acceleration? If the velocity is given by the derivative, 100 minus 10t, then the acceleration will be the derivative of the velocity equation, which means it's the derivative of the 100, which is 0, it's a constant, and then the derivative of the second term will be negative 10t to the power 0, which is negative 10, and the unit will be meters per square second at this stage. Because they said I have to use meters and second. Actually, that meters per square second is actually meters per second, because this acceleration is actually telling me how the velocity in meters per second is changing every second. The interpretation of this answer, we'll look at it a little bit later in one of the other examples. Let's look at a next example. The next example I have is about an ostrich named Roadrunner. Roadrunner runs from point A to point Z in a straight line, coming to rest at point Z. The distance in a straight line from A is given by this formula, where t is measured in seconds and s is measured in meters. So I've got this ostrich, fast running ostrich, coming to rest at point Z. The first question is, given expression for the velocity of Roadrunner. Okay, so what we already know is if this formula that must be given to me is the distance formula, what will velocity be? Velocity will be the derivative. So the derivative of that s, now I have to differentiate each term. 3 times 3 is 9, t to the power 1 less, minus, if you take the 4 to the front, multiplied with the negative half, which is already there, it's going to be negative 2t to the power 3. So, and that's what they asked. There is a formula describing the velocity. In the next question, they are asking me, so the same situation, what is the time taken to reach Z? So what happened at Z? That is important. At Z, what was the information? It said Roadrunner comes to rest at point Z. So it comes actually to rest there at point Z. It means actually he stops. He stops there. And if he stops there, he's not running anymore. What do we know? His velocity will actually be equal to 0. But in our previous question, we said velocity is described by this formula that we have used in the previous question. So I can just say the velocity must be equal to 0. So the velocity, which is 9t squared minus 2t to the power 3, must be equal to 0. Remember, I cannot divide with a t. It's an unknown. I don't know what it is. It could be 0, and I can't divide with a 0. It's not a linear equation, so I have to factorize. And how can I factorize? I can actually take out the highest common factor. In this case, I can take out a t squared. So 9 will be left, and if I take out t squared here, 2t will be left. So the one bracket must be 0 or the other one must be 0, which means t squared is equal to 0, or the 9 minus 2t must be equal to 0, which means t is 0 seconds, or the negative 2t is equal to 0. Sorry, it's equal to negative 9. The negative 2t is equal to negative 9. So t, if I divide with a negative 2 both sides, it's going to give me 4.5 seconds. 4.5 seconds. So now, why do I have two answers? Remember, what we actually calculated is where the velocity is 0. And the velocity was 0 here in the beginning as well. So the velocity was 0 there, because he did not start running yet there. So this is what actually is happening at point A. The time at point A is 0 seconds. But the time taken to reach point Z will be this 4.5 seconds. So this is the time taken to reach point Z. The next question that I have, it says, I have to determine the time taken to reach a maximum velocity before it comes to rest then at this point Z. So remember, for maximum velocity, the moment they say maximum, I'm actually determining the maximum of the graph. But the velocity graph, here we have the equation because we used it previously. I see it's actually a cubic graph, and a cubic graph has got this shape. So if I say I'm going to say the maximum is where the derivative is 0, where the gradient is 0. The gradient is not just 0 at the maximum, but it's also 0 there at the minimum. So I'm actually going to calculate the maximum and the minimum, and then I'll have to interpret which one is actually what I need. So here the gradient is 0, and here is the gradient is 0 at all the turning points, minimum and local max, it's going to be 0. So at the maximum velocity, we know the derivative of the velocity formula. So the velocity formula is given by this. I have to differentiate it and let it be equal to 0. So the derivative of that derivative, the derivative of the velocity formula will be, I have to differentiate this formula. So if I differentiate it, it's going to be 18t minus 6t squared. And what did we say? Let's just say it here. I know the second derivative must actually be equal to 0 at the turning points. So 18t minus 6t squared must be equal to 0, which means I can take out a 6t as a common factor. I have to factorize because it's a quadratic equation what I have. 6 goes into 18 3 times. I took out a 6t, so t is left in that bracket, and that is equal to 0. So let's just calculate what is the time. 6t must be 0, or the other bracket must be 0 for me to get 0 as an answer after multiplication. So t is equal to 0, or negative t is negative 3, which means t is 3 seconds. So let's interpret this. If I interpret this, remember I'm actually calculated the minimum and the maximum, because at minimum and local max, the derivative, the gradient was 0. So at t0 times 0 seconds, it's the minimum velocity. So the maximum velocity will be reached after 3 seconds before it comes to rest there at the point Z. A last question. The maximum acceleration of Roadrunner. Okay, so what will the acceleration be? The acceleration will be the second derivative, which is 18t minus 6t squared. For maximum acceleration, I actually have to differentiate the acceleration formula and let it be equal to 0, because maximums and minimums are reached where the derivative, the gradient, is equal to 0. So I have to take the derivative, which will be 18 minus 12t, and let it be equal to 0. So negative 12t will be equal to negative 18, and if I actually divide with a negative 12 both sides, I'm going to get 18 over 12, which is 3 over 2, which is 1.5 seconds. That is not the maximum acceleration. That is when it will happen. So I'm going to use the acceleration formula and substitute into t the time when the maximum will happen. So I have to replace every t with 1.5 seconds. And I'll end up having 13.5 meters per square second. The next example that I have, it's about an object blasted into the ground such that it reaches a depth of ft meters, where t is in time, the time in seconds. So here they say I've got the depth is described by this formula here. What is the depth? The depth is the distance it is going into the ground, downwards. Okay, so it's actually the distance. Let's put the depth. The depth is the distance. So the question is, what is the velocity of this object after 1 second? So the velocity will be the derivative of this distance formula. And do you see, I couldn't have just started off by differentiating, because I do not have this distance formula in exponent form. I still have to change it to exponent form. So let's quickly change it to exponent form. It's negative t to the power. You still remember that the inside exponent will get the top part of that fraction, and because there's actually a little 2 outside, it's negative t to the power half. So what is the derivative of this f of t? It's negative a half if I take that exponent to the front. T to the power 1 less, so it's negative a half. But I want to know what will the velocity be after 1 second. So I have to replace the t with a 1. And if I replace it with a 1, I'm going to get negative a half meters per second. Do you see this answer of the velocity came out negative? Why negative? Because this object is blown downwards into the earth. Okay, last question on this object that's blasted into the ground. The question here is determine the acceleration of the object after a quarter of a second. So what is acceleration? Can I remind you, we have just said the velocity is the derivative of the distance formula, the depth. So I have that already, and acceleration will be the derivative of the velocity formula. So for acceleration, I'll say it is the derivative of f. Negative, if I take that negative half times the negative half in front, it's going to be positive a quarter, t to the power negative 3/2. But they want to know what is the acceleration after a quarter of a second. So I have to replace the t with a quarter. And if I replace it with a quarter to the power negative 3/2, you'll have to take your calculator and actually calculate that value. And if you calculate it, you are going to get 2 meters per square second. Okay, let's quickly talk about the interpretation of this answer of acceleration. I have here a nice table that could guide me. If we look at this table, on the one side I've got velocity. Now velocity can be positive or negative. If we define positive velocity to be upwards or forward, and we define negative velocity to be downwards or backwards, and then the acceleration as we calculate it can come out positive or negative. So just to help me to remember the table, I use it like this. I say positive and positive will end up giving me positive. Negative multiplied with positive, so in this space here I'll get a negative. Positive multiplied with negative is the negative, and negative multiplied with a negative is positive. So if positive is representing speeding up and negative is representing slowing down, we can use the table to interpret what happened here. So I quickly calculated the velocity after a quarter second, and my answer was negative 1 meters per second. So if the velocity is negative, this object is blasted down into the ground, and the acceleration came out positive. So velocity was negative and the acceleration was positive. Then I get to this place here where it says the object is slowing down. So what's happening here is the object is actually slowing down. How is this object slowing down? It's slowing down by 2 meters per second every second. I want to talk for a moment about this unit. This unit can actually be written in different ways. I can say 2 meters per second, or that's the same as 2 meters per second divided by second, which is 2 meters per second multiplied with 1/second, which will be 2. Let's just leave out the 2 meters per squared second. Or you can write it as meters per second to the power negative 2 if you don't want that s squared to be below the line, but don't mix up the 2 units. I'm going to wrap up. What we have done in this lesson is we have used differentiation rules to actually answer questions on rate of change. In our next lesson, we are actually going to look at a third application of differentiation, which is cubic graphs. We are going to use differentiation to help me to draw a cubic graph. Thank you.